Okay. All right. So first off, I believe we've all downloaded the and installed Java in our machine. Okay, and also we have IntelliJ because the session is going to. I'll try as much as possible to make it um a hands-on session. Hands-on in the sense that it's not going to just be theories. Of course, any programming class should have some elements of practicals in it. So starting off, let me share my screen. Share this one. You can see my screen, yeah? Hello? Can anyone hear me?
Yeah, sure.
All right, so you can see my screen. I hope the record, I'm just sharing a window. I hope the recording will capture it. Okay, let me just share the entire screen. There's nothing. Stop sharing. Share the entire screen. Okay. All right, so let me know when you see the entire screen.
I can see it.
All right, so basic thing is first of all, this is the first class, and I started doing this I think around 2023. I do this, coach people for like maybe 3 months, and then at least give them some basic understanding that would let them stand on their own. But then I am still open to providing support. I am still open to providing support when they reach out to me. Maybe they want to learn a concept and stuff. And of course, like I said, it's free. I'm not doing this for the money. Just wanted to help and contribute to the society or to the community, developers community. So I'm not doing this for the money. Never going to ask you for money. If anybody asks you for money, just know that they've hacked my phone that day. Sha. First things first, if you're learning Java or any programming language, I think the first place to start, of course, is the variables and the data types and what's not, right? For Java is a okay. So does anyone here have any experience with Java? Let's start from there. Okay, you can speak up. I'm not seeing anything. I'm just sharing my screen, so I'm not seeing who raised their hand also.
Yeah, I have an experience with Java. Good evening,
Oh, okay.
everyone.
Okay. So like then I want to also let you know that, or let everyone know that this is like a beginner kind of class. It's not if you have an experience, you might feel like, oh, why are we doing some of the things we are doing? But I have found out that it's one of the ways I've found out that okay, I can actually help people learn. Then do you have anyone here have an experience with someone reached out to me, said he has an experience with C# already? Because C# and Java they are like siblings.
Yes, sir. I do.
Oh, okay, it was you. Okay. All right.
Yeah.
So Java, like I wanted to say, is a strictly typed language. Strictly typed means it's not like Python. Python and JavaScript is dynamic. So in Python, you can do something like this. Say name equals, you pass the value. You pass the value, right? In Java, you can't do it. Java, before you declare a variable, you must tell them the type the data type of this variable. You can't just say this equals this and then go on with your life. So you have to tell them this is the type I want this guy to be, right? So that makes it very important for us to, before even learning this guy, variables, which if you have basic understanding of programming is the same everywhere, we have to first of all learn about the data types. And that's why I created this first class and called it data type, because that's what we'll be focusing on today. And in Java, there are two types of data types. There are two types of data types. There is primitive data types, and there is also non-primitive data types, right? Those are the two types of data type we have in Java. Java would have been 100% OOP if not for primitive data types, because those ones are not objects. They are just like, they are just I don't know how to explain it, but they are just they are not objects. They are just some data types that hold values. Though they are when we progress, we also learn about the non-primitive data types of some of those primitive data types. That would be as we get deeper into the Java concepts and Java way of doing things in Java. So the primitive data types that we have in Java is int, which is the, I like doing this guy this way. I think what it to do. So it gives it this color. Okay, so there is int, there is long, there is short, there is bytes, there is boolean, there is char, there is float, there is double. I think that's about it. Int, long, short, bytes. Yeah, I think that's just about all the data types that we have in Java. So it's called primitive data type, right? Then the non-primitive data types, the non-primitive data types, So the non-primitive data types we have is number one is string, and array too is also, and then classes. Class is also a non-primitive data type. Is a data type, and we have interface. We have enums, and we have record. Depending on the Java version you're working with, I think this became a thing, I think from Java version 15. I am not sure, but I think from 15 or 17. I would check that. But if you are using older Java versions, say 8, 8, 9, and go. Did anyone raise his hand?
No, someone said Java 16.
Oh, from Java 16. Oh, yeah, thank you. Thank you. So if you are using older version of Java, you will likely not see this guy. So thank you for that input. I forgot where it became a thing. So this is also a type of data, right? So now that we know this guy, right? In Python, there are things we can do with variables. We have name equals this. In Python, you can say name equals this, and it will take it. It will just reassign this guy to an integer value, right? At this point. But here you cannot. In Java, you cannot. Whatever type you start a variable with, you have to continue with that. That is one of the things that makes Java a strictly typed language. So if you say here that this guy is going to be a string, you have to continue a string. If you say it's going to be a long, and then of course it will not allow you, because this is not how you define a long. So long has to be a value like this. Some people, they like putting in the L at the end. And then you come here and say, oh, I want it to now be a char. This is how you define a char. Oh yeah, I think it will take a char, because chars are also number underneath. It will take a char, but you can't say it's now a string. Yeah, you can't say it's now a string. It can't be a string, but char is a number under the hood. So I'll share some of the links with you guys. For those that don't know, you can just read up on some of the numbers assigned to each characters in Java. There are numbers assigned to each character. So this guy has a number assigned to it under the hood. The same thing with B, and then A has a different number from this A, right? So that's why when you are doing comparison, if you compare this A and this other one, capital A, it will tell you that they are not the same, because under the hood, the numbers assigned to them are different. And if you're working with char, you don't pass two characters. A char is just a single character. That is just something I wanted to get out of the way. So there is short, there is bytes, whatever. Like I said, whatever data type you assign here, you have to continue with it. And then the non-primitive types would go into all these guys in details. I don't know if anybody has any question.
Yeah, so I have a question, boss. So
Yeah, sure. Go ahead.
so basically, when I started learning Java at first, I think that was last year, I got confused with why we have primitive. What we mean by this one is primitive and this one is not primitive. I write Flutter, you get, and in that there's not like, okay, we have our data types, normal. Okay, so
Yeah.
why this one is primitive and this one is non-primitive?
Okay, so like I said, Java is object-oriented programming, and these guys are the non-objects kind of way to pass values around. If you want to do this, what is it called? If you want to do this with a wrapper class, it's called a wrapper class. You can do something like integer, and you see you can have access to this guy. It will show you some methods that is inbuilt you can use to manipulate your string, your integer values. There are methods that is there that you can use to manipulate your integer values. But with this guy, you don't have that kind of access. With integer, you don't have that kind of. It's just a data type that does not have any kind of, will I say, any kind of method under it. That's just a short definition of it. It doesn't have any kind of whatever value you pass to it. Though you can still work your way around manipulating the values, maybe converting it to string and doing all sorts. But non-primitive types have those things under the hood, right? They have some methods that you can use to manipulate the values under the hood. So that's one of the let's say key differences that I have seen so far.
All right, no, okay. Thank you very much, boss. Okay.
All right. So I'll just go ahead. Define some values using the data types that I listed here. So int, of course, let's say int x equals to this. What else again? We said double, long. Let's say long y. Then you can pass this value like this. You can also do it like this. So the reason people argue that you should add this L. You can do this capital L or small l, but it will throw you a warning that you should replace it with the low uppercase L. The reason is because some people said or I've read somewhere that when you pass this guy under the hood, it takes Java takes it, the Java compiler takes it as, because Java compiler is initiating this guy as a number. This is, oh, if you pass a whole number, it takes it as a whole number like this. Under the hood, it takes this long, even though you're passing this guy, it takes it as a whole number under the hood. So that's why they argue you should pass this guy. But if you don't, and you exceed the memory of an integer, the compiler will automatically, since you pass this, it will automatically assign them the same memory space that is due to a long immediately on the go for you, right? You don't have to maybe do any conversion or anything. If you exceed the memory space that is assigned to integer on a norm, and it checks, okay, this guy is a long, it just assigns it automatically. So whether you use this or not, you still get the same memory space that a long is supposed to have. But at this level, when you are doing it, it just assigns the same memory space that an integer has to it. But that when you exceed it, it now checks, oh, this is a long, and gives it more space. That's the reason I've read why people suggest you use this. But if you are not working on embedded systems that is very, very keen on memory space and what's not, I don't think you would ever have to worry about exceeding the numbers or the memory space assigned to this guy. But if you are working in a large system and you want your numbers, let's say, for example, you want to use something like UUID for your UUID is a type of type of data, this thing that is used for database IDs, right? So it's, the characters are long. If you want to, for example, use something like that, it's advised that you use a long for that. But because this guy has a shorter memory space than this, then we have a short. Short is also like a number thing, but just that in memory, it has a shorter memory space than this guy. So you can use shorts for if you're working with something like age, even though you don't have to, but it will go well when you're working with something like, that I don't think anybody has lived more than 200 hundreds of years and gotten into thousands and stuff. So this would work perfect for that kind of scenario. Then another one too is we have bytes too. We have bytes. So I think bytes too, you can actually use bytes for age or something. I don't know. This guy. You can also use byte because it has like a 3-character number. I think that's the maximum you can get. Yes, you can't exceed 3 digits on bytes. So then what else again? Boolean, of course, as we know, is either true or false. We'll go into that. Char has to be a single character. You can't do more than 1 character on char. Float is this. The same thing, the same reason I explained here why people add L here is the same. This is the same thing here, but now when it comes to float, okay, let me float and double. But when it comes to float, you can't define or apply this without getting an error, right? So under the hood, if any number, Java compiler takes it that any number that has a dot, it takes it automatically as a double, right? Then float is also the same thing. It has a dot, but there are instances where you want to use floats. Though if you are dealing with numbers, it's always advised to use double or another one called big decimal. So we will get to that later. But you are not advised to use floats because of what is it called again? You can miss rounding. When the number rounds, you can miss some values. And if you're working with money, even if it's 10 kobo, you don't want to miss that kind of value, right? It will affect the whole result. So you always should go with the double. I think, are we done with this? Float, char, boolean, right? Yeah. So these are the values that is associated with this guy, primitive types. I don't know if there's any question here. Okay, I'll take that like there's no question. So now we go to string. For string, of course, we have to say string this way. ABC, you can type till whatever, till Z if you want to. That is a string. Then we have arrays. First off, okay, let me just do this in, oh, yeah, these numbers, and this is how you define this. This is how you define an array in Java. I know it's different from other languages. I think it's the same. I think it's the same in C#. I've looked at it once, but I'm not 100% sure. So don't quote me on that. So this is how you define it and assign a value to it. If you just want to, I will also show you how to define it without assigning a value to it. And then you can also, in Java, like everything has a type, even your arrays. You can also have a string array. You can also have a string array and say names or something equals, then you pass the value. My name is Chidozie, right? And maybe another person's name is Emmanuel, and so on and so forth. Right? You have to define, first of all, you tell us the type of the array you want, then put this brackets, and then of course the name of your arrays. Is there any question on this? Then later we would work with these guys. We would work with these guys who would create this. But first off, you also have to know that we already have a class here. This is a data type. You can use it in another class, right? If we create another class, we can call this guy like this. It will accept it as a data type. But we'll look into it in more details when we start talking about OOP, objects, proper object-oriented programming. I don't know if anybody has any question at this point. Okay, sorry, let me plug my laptop. Yeah, go ahead, ask. I noticed.
Okay. So I just wanted to confirm the integer, like the array, like it just has, like, you just declare it. Is this the only way to declare it? That's more like the question.
No. I said I would get to that. I want to first give a proper definition of these guys. Then I'll get to how you can define. You can actually define it without passing the values to it
Okay.
automatically. You can define it and then assign the values to it later using indexes. Yeah.
Okay. Thank you very much. Thank you.
All right. So like we know, string is sequence of characters. That's what a string is. And array is a collection of similar values or similar data types. I know in Python you can come here and do something like this. You can't do it because it's not the same data type, right? You can't say, oh, this guy is an integer and then you're passing me a string. No, it won't accept that. So it has to be similar data types, right? Then the same thing here too. You can't come and say, oh, name, and then I want to add the person's age. It won't take it. So that's what an array is. It has to be a collection of similar data types, right? And it can be accessed using indexes. Would explore that later. And of course, the index it starts from 0 to n, where n is the length of the what's it called, array, right? So then classes they are called object blueprints. So what it is just, it gives you a way to create objects to house something that is related to a particular object. If we have a class that is for example, a person, now it houses everything that, or information that we want to know about a person: their name, their age, their address, whatever thing you want to know about a person. A class is that data type that holds that kind of information for you. Then interface is a collection of abstract methods that you have not implemented, but you want to use it. It's now the class that is implementing this method that will now define or maybe properly implement the methods. Don't be thrown away by the big implement this one, that one. We will cover all this when we get there. So at this point, just take it as on face value. A class implements interface, blah blah blah. Just don't be thrown away by all those terminologies. Sorry, I got a message. Okay, so an enum is it's sort of a data type that we use to define set of name values, like, or known values. For example, we know that in a week we have Monday, Tuesday, Wednesday, Thursday, Friday, Saturday, and Sunday. I don't know if we'll go that mad, but it's really good. I don't think it will ever change. There's no record of it. Well, maybe back in the days but I don't think it will ever change anytime soon in our lifetime. So we know these things. So if you want to, there's no need telling someone, oh, select, if you want to say, well, if you're working on a project that needs people to select a specific day, instead of telling people to type, because people would make mistakes, someone might not know how to spell a particular day, and then they'll go and type in whatever thing. And if you're now using it in your code to make some comparison, your code will be breaking, because where the person is supposed to put U, they went to put Z, and you're expecting or comparing U. Like you're comparing a value. Let's say someone is supposed to spell something like Friday, and you in your code, of course, being a smart engineer that you are, you're expecting Friday. Then the person now passed you the value, say Friday, like this, your code will be failing because you're expecting this. But enum gives us that opportunity to predefine these guys. So whatever thing that is coming, we know already, okay, this person is passing me this value. We are now comparing it. We are sure that this person is selecting from what we set, and we are also comparing with what we are expecting. It won't break, right? So we have Friday. You can have something like that in your enum. Another example also could be using enum would be when you are building an application that has gender, right? Even though, as we know the world we are in now, there are so many other things coming out. But if we are working in a project, I am working in a company that is based in the Middle East, and you know how strict those people are. So they don't do all this gender, this thing. They don't have room for that kind of stuff. So gender is male and female for them. So when I am working on a project, there's no need telling people to type in their gender. I just provide them male, female, they select, right? So if you are working in other applications or in a software that allows people the opportunity to choose whatever kind of gender they want, you can also provide that using an enum, right? Then a record is just a special data type that allows you to as a programmer to define a carrier data. You can just define values of a data and where you want to use it. You pass those values, and we'll explore all these things, right? So to your question about integers, so about arrays, so you can decide to define your array and say arrays equals, then you have to use the new keyword, then int. Then the thing is, you now have to pass the size that you want your array to be, or your list. You have to declare that, okay, oh, this my array, I want it to have only house 10 items, right? It shouldn't exceed. When you do something like this, what you're passing here will not be allowed to exceed 10. The values in this array is not allowed to exceed 10. If it exceeds 10, it will break your code. Then there is when we go deeper into this whole thing, there is another thing called array lists. Array list allows you to, dynamically pass values. It doesn't have, this is how you define an array list. It doesn't have size limits when you are creating it. So when you do your array.add, it keeps adding and it keeps making more space. It keeps making more space for you to add even more values. So this is how you define your arrays. In the data type, you pass this magical symbol, the name of the variable name. Then new is a keyword that you use to create a constructor or an object. We would get to that when we go into this guy properly, the data object-oriented programming. When we go into it, we'll explore this guy properly. Then, of course, you pass the data type again, and then you pass the value. I think in either C or C++, I don't know which one. I think you pass this guy here first. Oh, I can't remember, but I know one language you pass it first. And if you do, Java will allow you to do that, but it will tell you something like this is a C type or something. I can't remember how it allows you to do that. To tell you that this is a C type of defining array, yes, it's tell you your array has C style. So it doesn't break your code, but every language has their best practices, and this is not Java's best practice. Though it allows you, doesn't mean it's Java best practice. So it's always good to follow the coding convention assigned to the particular programming language that you are working with. So, do we have questions?
Yeah, sorry to take us back a bit. Please, it's
Oh,
at
sure.
what that char, right?
Yeah.
What instance do you use char?
To be quite frank, you only use it. I've only used char in interviews. I have never had any need for char in real world application. Let me think before I say something that is false. But I can't remember. Let me use the word I can't remember. I can't remember using this in real world application. It's mostly on interviews when they want you to say, if you're working on something like a palindrome kind of stuff, kind of algorithm, you can use char to split these guys and pass the value 1-1 and do your comparison. Maybe we'll get to working with maybe some data structures and algorithm. Maybe we'll just explore it when you want to manipulate or check values of if an item, if a string is a palindrome, you can use char in that instance. That is the only time I have ever used char. I can remember during an interview where I was asked to make some data string manipulations. That's the only instance I can remember ever using it.
All right, no problem, boss. Thank you.
All right. Any other question before we move to something else? Okay. So the next thing I want to talk about is the arithmetic operators in Java. Arithmetic operators in Java. So it's like, let me not say it's like, but in most cases, most of these things are the same across board. It's this, it should be the same thing in other languages. Let me say operators. So we have the we have the plus, we have the minus, we have the modular signs. Okay, let me do. I have this for as your plus sign. We have minus, we have multiplication. Let me add that color to it. Okay, we have this. We have this is for division. We have the modular sign, the division we know in our calculator. We have increments and also decrements. We'll look at all that. These are the arithmetic operators that we have. Then there is another one called relational operator. So option. There's another one called relational operator. Operator. Okay. And I think I can just do it this way. Can I do it? Let me see that asterisk this. Can I now make this guy to do? And it gives me that color going down. It doesn't give. Okay. Oh, I wanted to see if I break it, if it will continue with that color. Anyway, so we have relational operators, which when we're talking about it, we are using this for comparison. Is this? This is for comparison. This is the equal sign. Equal. Then we have not equal, like this. Not equal. We also have what else again? We have the greater than sign. This is greater than. Then we also have less than. We also have less than or equal. Sorry. Less than or equal. We have greater than or equal. So these are the types of relational operators that we have. I don't know. Do you have any question at this point?
No question.
Okay. So let me just show a quick example on how we use these guys. Of course, this one, I think you can just explore on your own, but let me just show a quick example on this guy. So let's say we have int number one, and then we'll pass value of this this is the same thing. If you know any sort of programming language, you should know this, what I'm trying to do. Number one, and then you have this other one too. So if you want to check which one is greater or something like that, you can go something like int results equals no. Oh, it won't be an int. It has to be a boolean. So this will return true or false. Simplify this. Oh, so it's telling me already that this guy is false, right? That's why it says simplify it, because number one is not greater than 90. It knows already. So if I even do like number two, it will just tell me to simplify it and make it true, because it's, if you look at these numbers, it's, if you simplify this guy, it's true. So that's what it does. We can just use this guy to do that. Then when the use case for this is most especially when we are looping through something, then we want to check before we take an action. If we have a list of items we are looping through to loops, we would explore that more. If we have a list of items we are going through and we want to check, or when we get to this particular condition, take this action. So we can use this. If maybe number is greater than is this one, that one, then do this thing. There's one of the instances where we use something like this. We can also use not equal, not greater than, not greater or equal, all this kind of stuff. Or we can even use equal, or we can even use not equal. So all those things, you will get to it when we are using condition, when we are checking conditions, right? So there is when we are working with operators, there is hierarchy. There is hierarchy when we are working with operators. Sorry. Oh, let me talk about logical operators before I get to the hierarchy. So there is another thing called the logical operators. So logical operators. So I don't know if it's this. No, it's not the same in Python. But so in Java, this is the way you do your AND. This AND. So you want an equals AND like this, right? Then your OR is something like this. This is OR. And we have NOT. This is NOT. So that's why we have this guy, not equal, kind of, because this NOT, we have equal, this is not, and then equal. So, and we also use this guy in condition, we're checking for conditions, you know. If A and B do this, if A and B plus this equals this, do this, you know, that kind of check. When we get to conditional statements and loops, we would explore these guys a lot. But there is this table I came across when I was learning programming. I can't remember, but when comparing something, you just know that when two things are true, when you have, for something to be true, using both of them has to be true. So you say something like this number one and number two, for you to get a true value, if your result, you want it to be true, both of them have to be the same, right? So if this and this, if you want your results, your Boolean value to be true, then two of them has to be true. Both of them has to be true. I'll look for that table. I saw it sometime online. I'll look for it and share in the group. So this and this has to, so the one on the left and the one on the right has to be true. for both of them to be true. So if one is false, the whole condition fails. It doesn't even check the one on your right. If it checks this one and if it's false, it doesn't even bother to check the other value. Then this or this is saying if one of them, if either of them is true, if this is true, then do this. If one is, let's say, if the value you are trying to compare on this side is true, it won't bother checking the other guy. It will just perform the action that you want it to perform. I would look for that table. I would just search and look for it and send and share in the group. It will help you understand these logical operators much better. And there's operators precedence, which means how Java, I think it should be the same across board for all programming language, but since we are focusing on Java, there's operator precedence, which means how Java evaluates these values. If you are making comparison or something, because if you are expecting, maybe you don't know these things, and then you expect it to maybe act in a certain way, but the result you are getting is different. You have to, number one thing you have to check is your precedence. So the precedence I use this, it's called PEMDAS. So P equals parenthesis. Is that the spelling? Parenthesis. Okay, parenthesis, which is parenthesis is this. So if anything is inside this guy, it gets checked first before any other thing. If you have a line of condition that it should check, anyone that you have in your parenthesis, it checks it first before it moves to the other one. So it's also exponents, then multiplication comes division, addition, and then subtraction. So this is the order it checks things. So if you want it to, if you have a value, you want to maybe add this value first before you now multiply it, you put it in a parenthesis like this. That's the precedence, operator's precedence. Our time is fast spent. Let me just quickly, before we ask questions, I know you might have questions. There's another other operators in Java operators. We have the ternary operator, and we also have something called instance of. So ternary operator is the same thing as your if statement, but now you are doing it in one line. It can be confusing and tricky at first, but it makes your code clean. Programming, I teach just says though you don't use. Okay, I'm hearing myself. Okay, when your sister, sorry, you ask question. When your teacher says, "Oh, don't use this when you are doing something," you kind of pick that bias and then run with it. So I use it when it's necessary, but in most times I don't use it. Then instance of is when you are comparing objects. So if you have there's something called generics in Java. So if you have if you're expecting an object, but you don't know the type of this object, let's say, yes, you are making a comparison and you're expecting an object. So there can be a data type kind of object, which is our class here. Our class here is called data type, right? There's another class called datas. So if you want to compare, if you want when the data that is coming is data type to do something different than when this one is coming, that's when you use this instance of. And a lot of people frown at this, because you can use polymorphism to achieve the same behavior, right? Instead of using instance of, you can use polymorphism. When we get to OOP, we will see how polymorphism acts. So polymorphism is something that takes a different behavior on the go, right? So if we want our system to behave in such a way that when the objects coming in is data type, do this. And instead of using this instance of, it's advised that you implement polymorphism in that case. So that way you don't have a lot of nested checks, because this guy involves a lot of nested checks. You have to, at least on this line now, you have to check for two things. If this thing is instance of this, do all this code. Then if it's now instance of this is another check. So you try to avoid a lot of nested checks. Someone raised his hand earlier. Can you ask your question?
Okay, I couldn't hear you. The network was breaking then, so that's why I raised my hand.
Oh, sorry. Can any other person hear me?
But it's clear now. After
Yeah,
I dropped my hand. Yeah. Thank you.
Okay. Well, everyone was hearing me, Abby. I just want to be sure it's probably just.
Yeah, I heard you.
Okay. All right. So do we have questions? I think it's almost 8. So let me just take questions, and if you have questions on the things that we've covered here today. Okay,
Okay, so
I like it.
it's
You guys, I like it. You guys.
Okay. I said I think it's that instance of I'm not really clear, though I understand the use case based on what you said, but maybe when we start working with it, that's the instance of.
Yes. So when we start working, you would see its use case. Some of these things here can be, of course, I think every other thing here is very clear, but these two guys can be tricky. But when you work with it enough, you should be able to get a hang of it. I just like, will I say, this is just basics, listing things that you can work with in Java, right? Listing things that you can work with in Java. When we start working with it in depth, you will have a better knowledge or better understanding of how to use those. So, is there any other question, or we can just end the session? Okay, so I have a quick assignment. For someone that knows programming already, it will be an insult, but for benefit of those that don't really know anything about programming, in fact, I will even insist everybody here does it. I'll even insist everyone here does the assignment. So this is just basic stuff, right? So step 1, declare and initialize values for the different data types and then print the values and modify the values of the variables. So I will send this to the group, and I would like everyone to do it, push it to your Git, and then share the link in the group. So I'll just take a look at it. Is that fine?
Yeah,
Yes,
that's
sir.
fine.
All right. So that brings us to the end of today's session. I would end the recording now. Is it okay? I'll end the recording now, and I forget how to do this.